Today we're going to learn about permutations. We're going to learn how to find a permutation and how to use that permutation to find probabilities. So to start, we need to talk about what is a permutation. A permutation is an arrangement or listing of objects in which order is important. So mowing the lawn, swimming, and then doing your homework is different from if you went swimming first, then you mowed the lawn, and then you did your homework third. Although you did the same three things, you did them in a different order. That would be a permutation. We're going to use our fundamental counting principle that we worked on the other day to find the number of permutations. So what does this all mean? So if I have 6 sailboats in a race, I want to know how many arrangements are there of first, second, and third place are there possible. Well, when all the boats are racing, there are 6 choices for first place. However, once a boat finishes first, there are only 5 boats that could get second place because one boat already finished first, and then there are only 4 choices left for third place. So I would multiply together. Kind of can't see at the bottom there, but it says 6 times 5 times 4. I'm not going to keep going the 3, the 2, and the 1 because I only care about first, second, and third place. And that would equal 120 when I multiplied those together. So if I have 5 people on a bowling team, if they all bowl one at a time, in how many orders can they bowl? So to do this, if I were going to be typing the names up on the screen, or on the scorekeeping screen, when I go to type the first person's name, there are 5 choices of who could bowl first. But after that, once one person's selected, there's only 4 people for the next spot. And then after that, since 2 people's names are already on the board, I only have 3 spots, and then 2 spots, and then finally 1 spot. This time I'm going to go all the way down to the 1 because I need to put all of them in order. So if I multiply 5 times 4 times 3 times 2 times 1, 5 times 4 is 20, 3 times 2 is 6, 20 times 6 is 120. And I could get out a calculator to use that if I wanted to, but right here it doesn't really seem like it's completely necessary. Okay, now I'm going to be at an ice cream shop. Carlos wants to buy a 3-scoop ice cream cone with 3 different flavors. How many cones could he buy if the order of flavors is important? So getting mint chocolate chip, vanilla, and maybe strawberry is different from getting vanilla, strawberry, and mint chocolate chip. The order that he gets them placed matters. So when he goes to select his first scoop of ice cream, he has 31 different choices. However, he's going to get different flavors. So when he goes to choose his second flavor, he only has 30 choices left. When he wants to choose his third flavor, there are only 29 choices left. I'm going to stop here because I only want 3 flavors, so I only need to multiply together 3 numbers. If I got a calculator for this one, I would get 26,970 different kinds of cones he could buy if he was just buying 3 flavors. That's a lot of different kinds of ice cream that can be made. Let's practice a couple more. So sometimes you're not going to have a word problem, and sometimes you're going to see some notation that looks like this. Okay, so what this means is I want to find, this time the P stands for permutation and not probability like we've seen earlier. I'm going to know that it means permutation because I'm going to have 2 numbers that look like an ordered pair inside the parentheses. The 31 is going to tell me what number I start with. So I'm going to start with 31. The second number tells me how many numbers I'm going to multiply together. So I'm going to do 3 numbers. So I would do 31 times 30 times 29 in that previous example. So if I have the permutation of 12, 2, this means I'm going to multiply out 2 numbers together. So what I would do is I would start with 12, and I would want 2 numbers together, so I'm not going to do 12 times 2, I'm going to do 12 times 11 because I'm counting down backwards. Okay, my next one, a permutation of 4, 4. So what I would do is I would multiply together, starting with 4, I need to go 4 numbers out. So if I go 4 times 3 times 2 times 1, I would now have 1, 2, 3, 4 numbers. I'm going to come up here with a question in the video. I want you guys now to do the permutation of 10, 5 written down on here, where you guys are going to just type it out. You don't actually have to do the multiplication this time. Just type out what you would get if it's 10, 5. Hopefully what you had answered is 10 times 9 times 8 times 7 times 6 That is 1, 2, 3, 4, 5 numbers out. Okay, let's try another one here. Sometimes we're going to see something with an exclamation point. This is something called a factorial. So factorials, if I see 3 exclamation point, it's not like an ELA when it ends a sentence. It's going to be something, a symbol that means something called a factorial. A factorial is just when I start with the 3 and I multiply all the numbers all the way down to the 1. So 3 factorial would just be 3 times 2 times 1. So 3 exclamation point or 3 factorial would equal 6. 7 factorial would just be if I started with the 7 and I multiplied all the way down to the 1. So multiplying a whole set of numbers out to the 1 is going to be called again a factorial. This is not going to come up in a lot of things that we do, but I think if you choose the GimKit today as one of your options, this will come up in a GimKit question or two. So just so you're kind of familiar with what that looks like. There is a button on your calculator. However, not being at school, it's really hard to show you where it's located. Okay, we could use our permutations now to help us find the probability. So if Ashley, and I had to cross out MP3 player because it shows how dated this book is, if Ashley's iPod has a setting that allows the songs to be played in a random order. So she's got a playlist that has 10 songs, very short playlist. But I want to know what is the probability that the iPod will randomly play the first 3 songs in order. So she has 10 songs listed, and I want to know, okay, what is the probability that if she listed the first 3 songs that they're actually going to play songs 1, 2, and 3 in order, and it's not going to start with like song 5, then 1, and then 2. It's going to go song 1, song 2, song 3. So what I would have to do is I would have to think about, okay, well, how many options are there for her first song? Her first song has 10 choices. Once that song is played, there's 9 choices for the second song, and there's 3 choices for the third song. So it'd be 10 times 9 times 8, which would equal 720. So there would be a 1 out of 720 chance for the 3 songs to play. So now I'm going to be looking at 2 more probability problems here. So if I have a swimming event features 8 swimmers, if each swimmer has an equally likely chance of finishing in the top 2, what is the probability that Yumi will finish in the first place and Paquita will finish second place? So here are my 8 different swimmers. So when I first start this out, I want to know, well, how many choices are there of Yumi finishing first. So for her to finish first, there's 8 ways for her to finish first. And then after that, there is going to be 7 people that could finish second place. So I have 56 different ways that first and second place can happen. But for Yumi to be first and Paquita to play second, there's only one way that that can happen. So I would have 1 out of my 56 total options. Again, I'm just figuring out how many different ways there are that first and second place can happen, which would be 56. Then I have 1 out of those 56 ways that it could be exactly Yumi and Paquita. Now I'm going to be looking at this random word called math. I wonder why that word was selected for the lesson. If I want to have 2 different letters that are randomly selected from the word math. So if I have 2 different letters that are my first letter, I have 4 choices of which letter could be picked first. Then I have 3 for my second one. So I'm only picking 2 different letters. There are 12 different outcomes that could occur. So I want to know what is the probability that M is selected and then H. Well, there's only one way that M and H could be selected, so my probability would be 1 out of 12. Most of the time, it's just 1 out of the total number of outcomes you're kind of seeing here with the probability. Okay, what I want you guys to do right now is if we have these Simpson characters that are getting to, there's 5 of them, but only 3 of them get to be chosen to go on a safari in Africa. How many possible trios are there if the order matters? So Bart, Krusty, Maggie is different grouping choice than Maggie, Krusty, Bart. Don't ask me why, it just is. But the way they get on the plane and they sit in the seats, it's going to be different. So I want you guys to think about how many different possible trios there would be. Okay, so I'm going to click off to show you all the different possible trios that there are, and you can't even see them because there's so many on here. So if we look at this on here, we could see that if I were to multiply together and find all of them, here's actually my sample space of all of the numbers. But if I were to figure out where I have space to actually type this on here, do this, there are 5 people that could go first. There are 4 people that can be chosen second and 3 people that can be chosen third, so I would have 120 different ways. Again, here's the sample space of the 120 different ways. I did not type all those up. I did find the slide online. Okay, one last problem for you to practice. The locks on your locker go from 0 to 39, so there's 40 different numbers. How many different 3-digit codes are there for opening a lock if there is no repeating digits? I want you guys to think about all the different possibilities of locker combinations you could actually have. Again, we're not going to repeat digits. So if you have a 5 for the first number, it's impossible for you to have a 5 for the second number. No, that's not how our lockers really work, but we're going to pretend for this example. And I want you guys to figure that out. You probably are going to need to open up a calculator on your computer or have one out in front of you. Okay, so what we would do is we would do 40 times 39 times 38, and you should get an answer of 59,280. So that's how I would do permutations.